This tutorial shows you how to run the mark-recapture software Mark under R. This is easier than running Mark standalone. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system, although it can also be performed using other operating systems. The crucial element is to first install Mark on your computer following the instructions on the developer's website, which I have linked in the show notes below. But you can also skip all of that and use my pre-configured Ubuntu Linux virtual machine that already has everything you need pre-installed. This virtual machine will work on your Windows or Mac computer, and it comes pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. This tutorial assumes you have RStudio installed on your machine, which also requires R to be installed. I have a tutorial for this in the show notes below, or you can use the pre-configured virtual machine that I already mentioned for this purpose. This tutorial also assumes you already have the program Mark installed, as well as the R package RMark. I have a tutorial showing you how to do this for the Ubuntu Linux operating system. See the link in the show notes below. Or you can skip all of this and use that pre-configured Ubuntu Linux virtual machine that already has everything all set up and ready to go. Let's go ahead and get started. Open up a browser window, which I have pinned to my favorites on the left, or which you can find by searching below. Navigate to my website, joshbanta.com. Click on Tutorials. In the table of contents, scroll down to where you see How to use the mark-recapture program Mark under R, and click on it. Then click on Files Needed for Tutorial. Click the Download button. When the download is complete, you may close the browser window. Next, open up File Explorer, which I have pinned to my favorites on the left, or which you can find by searching below. Navigate to your Downloads folder. Double-click on the file we just downloaded, rmark.zip. This shows us the files within the zip archive. We need to extract these files from the zip archive into an uncompressed format in order for them to be available for us to use. Go back to your File Explorer window. Click on Desktop. From the menu at the top, click the downward-facing caret and select New Folder. Name the folder RMark and hit Create. Double-click on that folder. Now move the File Explorer window over to the side, and we want to drag these files from within the Archive Manager software out into the RMark folder on our desktop. Now you may close the Archive Manager software. You may also close the File Explorer window. This is a quick splice to ask you to consider subscribing to my channel by hitting the subscribe button. It does not cost anything. It is totally free. But if you like what I am doing and want to support my work, I encourage you to visit patreon.com/joshbanta and make a voluntary contribution. The link is in the show notes below. Your support helps me to deliver new content and keep this channel current and vibrant. Thank you. Let's look at the format of the input data. Double-click on the RMark folder on your desktop. Highlight the file sample data for mark.csv. If you are on a Windows computer, right-click with your mouse. If you are on a Mac, push down on the trackpad with 2 fingers. Select Open with Other Application. Select View All Applications, and then choose Text Editor and click Select. For this R script to work, you need to have one column with your ID numbers. Call it tag number. but that can be any unique identifiers of individuals. The next column is called CH, and that has to be lowercase ch. That column is the capture histories of each of those individuals. So on this first line here, this individual with the ID number 1684003 was captured on the first visit, was not observed on the second visit, was captured on the third visit, and was captured again on the fourth visit. And we know that this was the same individual because with a mark recapture study, all of your individuals are uniquely marked somehow during their first capture, so you know when they are recaptured. In the third column here, we have the species. Now, this data set is set up for different species, but you could instead use, if you had just one species, your groups could be different sexes, male and female, or something else. But the way that I have this script set up to work is for different species. So you should have the exact, in your real data, you'll be using the sample data today, you should have the exact same headers that I have here, and you should have your data formatted exactly the same as mine here. Now, this format may look unfamiliar to you because it doesn't look like a spreadsheet. It has the data and commas. This is a comma-separated file. This is the simplest way to save spreadsheet data that can be read into any program, including R. It's not proprietary, unlike other file formats such as the .xlsx format of Excel. But we can also read this file into spreadsheet software such as on this computer, LibreOffice, to see how it looks in a traditional spreadsheet program. Let's go ahead and do that. So we'll close out of this file in TextEdit. Now we'll simply double click on it to open it up in LibreOffice. Accept the defaults and click on OK. Now here's the problem. Let's go back to this first individual. Now, overall, you can see that the file was imported properly into the spreadsheet software. The spreadsheet software knew how to import this comma-separated value file and to use the commas to indicate the breaks in between different columns. And again, for this first individual, we can see that they were captured on the first visit, they were not observed on the second, and they were captured again on the third and fourth visits. But let's look down here at row number 7 at this individual. Why is there only the number 1? That's because this individual was actually 0001, meaning that this individual was not observed on the first, second, or third sampling events and was only observed on the fourth and final one. The problem is that when this file is being read into our spreadsheet software, which is LibreOffice or it could be Excel on your machine, all of those leading zeros are automatically removed. And they're removed from the data. They're not there in this version that is now open in LibreOffice. So that's a big problem, and that's why I recommend, instead of using LibreOffice, that you edit your spreadsheet with your data using Text Editor. There are 2 more issues that I want to draw your attention to here. The first has to do with exact spelling. The software is very sensitive to how things are spelled and to punctuation. So, for instance, if I were to put in a space here, the RMark software would treat this individual as a different species from all of the rest down here. This individual would be thought of as space three-horn wartyback, whereas the rest would just be known to the software as three-horn wartyback. So you have to be very, very careful that there's no extraneous spaces before or after and that they all match. Another point along those lines is spaces and capitalization. So let's see that here we have 3 individuals of the species known as 3 ridge. Notice that there is a space in between 3 and ridge and that R is capitalized in ridge. Now down below here we have more individuals of that same species 3 ridge, but there is no space in between 3 and ridge, and the R is lowercase in ridge. The RMark software will treat these individuals down here and these three ridge individuals up here as different species. So we have to make the names match exactly. So go ahead and fix that in your data set. The next item to draw your attention to has to do with your capture histories. Take a look at this individual down here. This individual has 0, 0, 0, 0. Something is wrong. That means that this individual with this ID number was never encountered. That can't be. If this individual was never encountered, how does this individual have a unique ID number? How was this individual ever tagged to get that unique ID number? This is impossible. So you need to make sure that you don't have any individuals like this in your data set. Now, for the purposes of this tutorial, I am just going to remove those individuals. So that one is deleted. I'm going to type Control F, and I'm going to do a search for 0, 0, 0, 0 to see if there are any others. Here's another one. Okay, Control F. And here's 2 more. So go through and get rid of all of those individuals that are 0, 0, 0, 0. I can tell that I've gotten rid of all of them because when I hit the up and down carets here in the search window, nothing comes up. So now that everything is fixed, I will go ahead and click Save. Now you can close the text editor window. Let's go ahead and run the script. Open up RStudio, which I have pinned to my favorites on the left, or which you can find by searching below. Click on File, Open File, navigate to your desktop, double-click on the RMark folder. I'm going to show you 2 different R scripts today. First, open up RMark Species Data Popan by double-clicking on it. I have background reading here if you want to understand more about how mark-recapture software works from a theoretical standpoint. Set your working directory by going to Session, Set Working Directory, and set it to the source file location. Your source file location needs to be the folder that has both this R script in it, as well as any other files that you will be importing into R. You cannot have any of those files in subfolders. Next, if this is your first time running this particular script, you need to install the RMark package. And the way you do that is to highlight the entire command on line 18 except for the hash symbol. Now, if you are in my class, do not do this. Do not run line 18 if you are in my class. It is already installed. But if you are not in my class, you will need to highlight this line without the pound sign, which we call a hash or a comment, and you would click on Run. Next, go to line 23 and click on Run. Now we need to call the library RMark. Go to line 27 and click on Run. We need to start fresh, so remove any other R objects that may be sitting in memory. Click on Run. Click line 31, Run. Now we need to read in our data. We have the data in that CSV format. We need to turn it into an R object, which I'm calling here species data. When you are using your own data, you would change the name of this file to match whatever the name of your file actually is. So be sure to change that, or you'll just be running the sample data when you're trying to run it on your own data. For running this tutorial, we're going to use the sample data. You can leave this as it is. So highlight lines 34 through 36 and click on Run. Next, we need to modify the data format slightly. Go to line 40 and click on Run. I am showing you in this first example here how to run the software Mark, but I am showing you how to use it for a model called Popan. There are other models that you can use, such as, for instance, CJS is another very common model type, and I will show you that next. But for this first example, I'm going to show you what it is like when you run it with a Popan model. Highlight and run lines 59 through 63 and click on Run. Now we are going to run multiple models and find the one that best fits our data. To do this, we have to define the formulae for the models. Lines 73 through 75 are formulae for the parameter p. P is the probability of detecting an individual of a given species at each of the times when you performed your sampling. The first line is a model where the probability of detection is the same for all species at all time points. The second formula is for a model where the probability of detection is different for different species. And the third formula is for a model where the probability of detection is different at different sampling events. So for instance, if the probability of detection were different for your first sampling trip than for your second sampling trip. Going back up, lines 67 through 69 are formulae for the parameter phi. Phi is the probability of an individual surviving from one time when you performed your sampling until the next time when you performed your sampling. Lines 79 through 81 are formulae for the parameter PENT, which stands for probability of entry. Lines 85 through 86 are formulae for the parameter capital N. Note, this N does not refer to the population size. I will not explain more about PENT or this capital N parameter because I do not want to make things confusing. These are parameters that must be set in order for the equations to work, but they are not of central importance to us. Highlight lines 67 through 86 and click on Run. Now we will run all combinations of models with different parameter formulae and find the best one. Highlight lines 93 through 95 and click on Run. This will take a few minutes. Now look at the comparisons among models by clicking on line 98 and clicking on Run. You'll need to click on the console window down here, and then you'll need to scroll up a bit. What we're looking for is the model that appears first at the top row. This is the model that has the lowest AIC value. This is the best model. You can read more about AICs. I will put a link in the show notes below, but that is how you determine which is the best model. In our case, the best model is one where all survival probabilities are set to be the same for all species at all different points in time, where all probabilities of detection are set to be the same for all species at all points in time, and where those two other parameters, PENT and capital N, were also set to be the same for all species at all points in time. Now we will run just the best model to get our results. We need to set the parameters phi, p, PENT, and capital N on lines 102 to 105. We need to set these to whichever match the best model from our data. Now, with the sample data, in this case, it's 1, 1, 1, 1. So that's why there's a 1 here, a 1 here, a 1 here, and a 1 here. But if this model were the best, if this model were on top, Then we would set phi to 1. Then we would set phi not to 1, but we would set phi to time. So instead of a 1 here, this would be time. And then everything else would continue to be a 1. So whichever is your model that ends up being the best up here on the top, that's what you would set. Highlight lines 102 to 105 and click on Run. Now we run the best model. Highlight lines 109 to 121 and click on Run. Now let's generate the results and save them to a file. Highlight lines 125 through 139 and click on Run. Now let's look at those results. Click on File Explorer, which I have pinned to my favorites on the left, or which you can find by searching below. Navigate to your desktop and double-click on the RMark folder. Click the tab that says Modified to sort the items in the folder by the date and time that they were modified. Double-click the file species mark-real to open it. Accept the defaults by clicking OK. These are the real estimates, where real just refers to the parameters phi, p, pent, and capital N. It doesn't have anything to do with being genuine, bona fide, or not fake, or in the right format. It doesn't have anything to do with any of those things. On row 2, we see phi. The estimate is 1, and the confidence interval around that estimate is also shown. It says climber, which is one of our species, but there are no other rows for phi. This means that the phi for climber is the same as the phi for all other species at all other time points, even though the others are not shown. This is expected because we constrained the model to set phi to be the same in all instances. If we would have, for instance, set phi to vary depending on species, then we would see multiple rows for phi here with a different phi estimate for each species. On the next row, we see the estimates for P and N. Remember that capital N here is not the population size. Again, only one row is shown for each because the other species and other time points are the same for these parameters as the ones that are shown. PENT is displayed differently. Each species and each time point is always displayed no matter what. This is a quirk of the Mark software. But notice that all values of PENT are the same on all rows. This is because we constrained PENT to be the same for all species and at all time points. Go ahead and close this file. Double-click on species-derived mark-n.csv to open it. This does show population sizes. So-called derived estimates, as Mark calls them, show you what you want. You can see the estimates of population size for each species for each time point, meaning each sampling occasion. Go ahead and close this file. Double-click on species-derived mark nbyocc.csv. This shows the estimated population size overall across species at each time point. Go ahead and close this out. Double-click on species mark ngross.csv. This shows an estimate of the gross population size for each species at the last time point. Gross here has a very specific meaning. It means the population size of those available to be marked and recorded, plus individuals that entered the population after the last sampling occasion, who will leave the population again or die before any future sampling event. Go ahead and close this out. Now we will open a different R script. Click on RStudio and then select File, Open File from the drop-down menu. Navigate to your desktop, double-click on the RMark folder, and then scroll down and highlight RMark Species Data CJS and click on Open. This is to show you how to run Mark with a different model type. In this example, the CJS model type instead of Popan. This script is modified primarily on lines 59 and 83, where the model type is set to CJS instead of Popan. But also the parameters PENT and capital N, which does not refer to population size, are absent. The CJS model type does not use those parameters. Highlight lines 31 to 85 and click on Run. Find the best fit model by clicking on line 88 and clicking on Run. Set the formulae for phi and p on lines 92 and 93 accordingly, and then highlight those lines and run them. Then highlight and run lines 97 to 112. Let's look at the results. Click on File Explorer and open Species Mark Real CJS.csv. This contains the estimates for phi and p, which will be the same for all species. If we had selected different formulae for phi and p, there would be more rows here, for instance, different phi's for different species and different p's for different species. You have now completed the tutorial.